In today's lecture, we're going to look at clock and modular arithmetic. But before we start the worksheet, let's go over some background information. Here is our 12-hour clock. Notice the 12 starts at the top, and we're going to count 1, 2, 3, 4, all the way to 12 in a clockwise fashion. This system is very similar to the base 12 system. The only exception that we have is that you have no zero. The 12 here is kind of like our zero in the clock system. Now, when we're doing addition in the clock system, we always add clockwise. When we're doing addition, again, we add clockwise. For example, if I start at 2 and I add 2 to it, I would go 1, 2, and end up at 4. So 2 plus 2 in the clock system is equal to 4. If I were to do subtraction, that implies I need to do counterclockwise. For example, if I have 6 minus 2, I will start at the 6 and then subtract, which means going counterclockwise. 1, 2, and I will end up at 4. So again, just remember, for addition, we're going to go clockwise. For subtraction, we're going to go counterclockwise. Now, why did I say 12 acts kind of like a 0? Well, think about this. If I were to start at 1 and add 12, I would end up back at the same place. So 12 acts kind of like 0. Now 0 is the identity for addition. What I mean by that is, consider 5 plus 0. You're going to get 5 back. The 0 is the identity for addition. 0 is the identity for addition. So that means whatever I add with 0, it gives me the same thing back. So again, 0 is the identity for addition. We know that 0 is our identity for addition. What about in the clock arithmetic? For the clock arithmetic, the identity is going to be 12. 12 acts like 0. For example, if I have 5 and I were to add 12 to it in clock arithmetic, I will end up at the same place. So 5 plus 12 equals 5 in clock arithmetic. So 12 is our identity. Now, how do we find an inverse? Well, before we do that, let's look at regular arithmetic. We know 5 plus 0 equals 5. So 0 is our identity for addition, regular addition. Now, if I want to find the inverse, we would have to ask 5 plus what gives us our identity back, which is 0. So what is the inverse of 5? The inverse of 5 is going to be negative 5, because when you add that to your number, you get the identity back. So negative 5 is considered our inverse. And this inverse is for addition, regular addition. Now let's look at the other side. Let's look at clock arithmetic. For clock arithmetic, we know 5 plus 12 gives me 5 back. 12 is our identity, and that's for clock arithmetic. Now to find the inverse, I would have to say 5 plus what gives me the identity back, which is 12. So in this case, 5 plus 7 gives us 12. So 7 is our inverse. And this is our inverse for clock arithmetic. So there's two sides of this. For regular arithmetic, 0 is our identity. So to find the inverse, you have to figure out what we need to add to our number to get the identity. For clock arithmetic, 12 is our identity. So to find the inverse of a number, we have to figure out what we need to add to our number to get the identity 12. Now let's try the worksheet. Part A, on a 12-hour clock, find each of the following. We want to find the additive inverse of 3. And remember, this is for clock arithmetic. So to find the inverse of 3 for clock arithmetic, we're trying to figure out 3 plus what will give us the identity. Remember, the identity for clock arithmetic is 12. So 3 plus what gives you 12? This is 9. So we know that 9 is the inverse of 3. For question 2, we're asked, what's 1 plus 2 in clock arithmetic? So we'll draw our 12-hour clock. Now we're starting at 1, and we're just adding 2. So we have 1, 2, added to that, we end up at 3. So 1 plus 2 is equivalent to 3 in clock arithmetic. Now in example 3, we're starting with negative 3 plus negative 10 in clock arithmetic. So let's draw our clock. What is negative 3? Negative 3 would be starting at 0, then going counterclock 3 times. So that's 1, 2, 3. So this is negative 3 in clock arithmetic. And then we're going to add negative 10 to that, which means we're going to go counterclockwise 10 times. So starting from 9, we're going to go counterclockwise 10 times. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So negative 3 plus negative 10 in clock arithmetic is 11. For question 4, we have 3 plus 10 and then a negative in front of the expression. So let's again draw our clock. For question number 4, let's draw our clock again. We're going to start at 3, and then we're going to go clockwise 10 times. So that's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we're going to end up at 1. So we have 3 plus 10 is 1. So negative 3 plus 10 equals negative 1 in clock arithmetic. But what's negative 1 in clock arithmetic? That is equivalent to 11, because 0 is 12. We go to the left 1. That is 11. So negative 1 is equivalent to 11 in clock arithmetic. So please pause the video and try these questions on your own. Let's try question 5. We have negative 3 minus negative 11. So we're going to draw our clock again. And we're going to start at negative 3. Well, where's negative 3? That's going to be to the left of 12. That's 1, 2, 3. So 9 is equivalent to negative 3 in clock arithmetic. Now we have a negative of a negative. So we're going to go the opposite of negative 10. So we're actually going to do plus here in clock arithmetic. So that means we're going to the right 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So our solution is equivalent to 7. Let's look at 10 minus 5. 10, we'll start at 10, and then we're going to go counterclockwise 5 times. 1, 2, 3, 4, 5. So we end up at 5. For 6 times 3 in clock arithmetic, we will again look at our clock. Now 6 times 3 is equivalent to 18, but 18 does not exist in clock arithmetic, so 18 is wrong. But where would 18 be? Well, you can count 1, 2, 3, 4, 5, 6 all the way to 18 and figure out where it is if that's what you want to do. Or I can do 18 divided by 12, since our clock system acts like a base 12 system. 18 divided by 12 is equivalent to 1 remainder 6. So I know I'm going to go in a circle one time and then land on 6. So 6 times 3 in clock arithmetic is not 18, it's actually equal to 6. The 1 tells me it goes one full cycle around, and then we're going to land on the 6. So 6 times 3 is 6 in clock arithmetic. For question 8, before we try the problem, let's consider regular division. If I were to ask you, what's 8 divided by 4 equal to? You would say it's 2. But why is it 2? Because we can write this as a multiplication problem. 4 times what will give me 8? And of course the answer is 2. To do question 8, it's very similar. Instead of asking what's 4 divided by 7, I'm going to ask 7 times what in clock arithmetic will give me 1. So now we have to guess. I could do 7 times 1, 7 times 2, 7 times 3, 7 times 4, 7 times 5, 7 times 6, until we get our number. But remember, you can make our lives a lot easier if you think of this as a base 12 system. So what's 7 times 7? Well, that's 7. That is not our answer. What's 7 times 2? That's 14. But when I divide it by 12, I get a remainder of 2. Again, think of the clock system as a base 12 system. 7 times 3 is 21. 7 times 3 is 21, but when we divide by 12, we get a remainder of 9. 7 times 4 is 28, but when we divide by 12, we get a remainder of 4. 7 times 5 is 35, and so this is equivalent to 11 in clock arithmetic. 7 times 6 is equivalent to 42, but when you divide that by 12, we have a remainder of 6. 7 times 7 is 49. Divided by 12, we finally have a remainder of 1. So 7 times 7 is indeed equal to 1. Therefore, 1 divided by 7 is equal to 7 in clock arithmetic. Part B, let's perform the operations on a 9-hour clock. So let's consider our 9-hour clock. 9 would be at the top, and we'll count 1, 2, 3, 4, 5, 6, 7, 8 in a clockwise fashion. What's 6 plus 1? Well, we'll start at the 6, and we'll go clockwise, and we have 6 plus 1 is equal to 7. Again, for 8 minus 8, we'll start with a 9-hour clock. And then we'll start at 8 and go counterclockwise since we're subtracting 8. We'll count 1, 2, 3, 4, 5, 6, 7, 8. So this gives us 8 minus 8 is equivalent to 9. What's 4 times 8? Well, remember, 4 times 8 is 32, but that does not exist in a 9-hour clock. Our 9-hour clock is similar to a base 9 system. So what's 32 divided by 9? That is equivalent to 3 remainder 5. So 4 times 32 is not. That implies 4 times 8 is equivalent to 5 in our 9-hour clock system, because 32 divided by 9 is 3 remainder 5. For question 4, I want to consider the multiplication version of this question. 3 times what is going to give me 4? And we'll have to check. 3 times 1. 3 times 2. 3 times 4. 3 times 5. 3 times 6. 3 times 7. 3 times 8. 3 times 9. And that's all of them for a 9-hour clock system. So please try these on your own. And again, when you get your number, divide by 9 to convert it to a 9-hour clock system. This one is 3 times 1, which is 3. 3 times 2 is 6. 3 times 4 is 12. But that is equivalent to 3 when you divide it by 9. 3 times 5 is 15. And 15 is equivalent to a remainder of 6. This is equivalent to 6 when we divide it by 9. 3 times 6 is 18, or a remainder of 7. 3 times 6 is 18, but when we divide it by 9, we have a remainder of 0. 3 times 7 is 21, but when we divide it by 9, we have a remainder of 3. 3 times 8 is 24, but when we divide it by 9, we have a remainder of 6. 3 times 9 is 27, but the remainder is 0 when we divide by 9. Of all of the possible cases, we do not have a situation where 3 times a number in a 9-hour clock system gives us 4. There is no way we can create a 4 by multiplying with 3, so this implies that 4 divided by 3 is undefined. We have a mistake. Unfortunately, I made a mistake. I forgot about something. Remember, 0 does not exist in a 9-hour clock. 0 does not exist in a 9-hour clock. So these zeros are wrong. They should actually be 9 because our identity for addition is 9. 9 acts like the 0. So please correct that. My mistake for making that error. Part C, let's perform the operations with a 4-hour clock. Again, 4 will be on the top, and then we'll go clockwise. 1, 2, 3, 4. Now, what's 1 plus 3? We have a 1, and we'll add 3 to it. 1, 2, 3. So 1 plus 3 is equal to 4 in a 4-hour clock system. For 1 minus 3, we have to start at the 1, and we'll go counterclockwise 3. That's 1, 2, 3. This is equivalent to 2. Now let's consider 1 times 1. 1 times 1 is equal to 1. 1 does exist in a 4-hour clock system, so that's our solution. For question number 4, we have 2 divided by 1. Let's change this to a multiplication problem. We're going to ask 1 times what is going to give us 2. So we'll have to guess 1 times 1, 1 times 2, 1 times 3, 1 times 4 until we get a solution that is equal to 2. What's 1 times 1? Well, that's equal to 1. 1 times 2 is equivalent to 2. So that's our solution already. We know that 1 times 2 is equal to 2. So we know that 2 divided by 1 is equal to 2. And of course, some of you might have already seen that, but we just wanted to go through the process just in case you didn't know